Have you ever been outside in nature, maybe at a county park, and looked at some of the beautiful trees and wondered, how tall is that tree? Well, if you have, this is the video for you. I can teach you how to do it. I was in the Forest Service. I'm a science teacher now. I've used this for freshman biology students. I think you'll enjoy it. Here's the basics. You need a clinometer. This, you're gonna look through the site and then look up at the tree, and you're gonna get a reading and know the degrees off the ground the top of the tree is. You can also use a protractor, and I'll show you how to do that later. Then you need some way of measuring the distance from yourself to the tree, so you need a laser rangefinder or just a tape measure. And then we are doing a trig function, so it might sound intimidating, but it's just one simple button on either your phone or a typical calculator, and it'll give you the answers we need. Let's do this demonstration at least twice. For this smaller tree, that's still a redwood tree, we're gonna do that one, but then we're gonna do that middle one after that. All right, the best way to teach this and the best way to learn this is by drawing a model, make a model, okay? That's one of the scientific methods. You set up a model to demonstrate the real life situation. So you're making your model. Our model is gonna start with the tree, then let's draw me, or the observer. It could be you, it could be anybody. Some distance away. Now when you look at this model, you can already see it starts to look like a geometric shape. What shape is that? A triangle, right? So let's draw that triangle. Let's draw the triangle from how we're observing the triangle. So we're observing it from our eyesight. We're going to observe to the tree. We want to know how tall the tree is. Okay, so we can already see that when I look at that tree over there, it's going to create a triangle. Some terminology for triangles that you need to know. This one, the angled one, is called the hypotenuse. This one's called the adjacent. And this one over here is the opposite. Now this one's called the adjacent because it's adjacent to the observer. This one's called opposite because it's the opposite line to the observer. So now we need to figure out variables. There's going to be variables we know and variables we don't know. Some of the variables we don't know, well, some of the variables that we will know that we can measure is this angle. That's what the clinometer is for. That little zero with the line through it is called theta. It's Greek. It's just like a placeholder for an angle. We can measure theta, so we're going to know theta. We're going to know what that theta is. We're going to know what the adjacent is because we can measure that either with a tape measure or with the laser rangefinder. So we're going to know this. We're measuring the opposite because we want to know the height of the tree, right? So we're measuring for the opposite. So the opposite is the unknown. The opposite is unknown. Now, the hard part if you haven't been into trigonometry yet or beyond is the trig functions. Now these are just math functions. You're not going to have to know how to prove them or derive them or anything. All you have to know is plug and chug. I'm going to show you the equation. You just use the key on either your iPhone, I'm sure Androids and other phones have it too, or your calculator. There's this moniker known as SOHCAHTOA. The S, C, and T stand for the trigonometric functions. That's the sine, that's the cosine, that's the tangent. The O's, A's, and H's stand for the opposite, hypotenuse, and adjacents. Okay, we need one that does not include the hypotenuse because we don't know the hypotenuse, so that automatically leaves this one. So we are solving for the tangent of the opposite over the adjacent. So this one's going to be the tangent. So we know that the tangent of theta is going to equal the opposite over the adjacent. That's what that thing is. You don't have to understand what it means, you just have to understand that's what we're doing. So now let's go out there and let's measure theta, the angle, and let's measure the adjacent, the distance to the tree. First step is the clinometer. You look through the clear path, line up the line to the top of the tree. Just to the right of that is the number in degrees. Next, I can either use the laser rangefinder or a tape measure to get my adjacent distance to the tree. You can get a cheap clinometer like this one on Amazon for like 20 bucks. But if you don't want to do that and you have a projector, you can easily make one on your own. I put a little straw on the top. That part's not even necessary. You do need to hang a string down with a little bit of a weight. And when you look at it, if this were level, the string's gonna go, look at the outside numbers, go to right to 90 degrees. Can you read that from that angle? Yeah. Go right to 90 degrees, right? So as you tilt this up, as you're looking at the top of a tree, it's gonna go to a higher degree. And then you're gonna have to do the math. You're gonna have to go 90 degrees, and if we look up and it's at 70 degrees, let's say up to 50 degrees, between 90 and 50 is a 40 degree difference. So you're looking, your theta would be 40 degrees. Let's practice this. There's a tree over here. Looking up at the top. I'm gonna pinch this so I know where it is. It looks like about 75, so maybe 15, maybe a little bit higher, maybe about 17 degrees. Now let's take the clinometer. And closer to 20, it looks like 19 or 20, but it's still pretty darn close. So make yourself a clinometer, it's really easy. All right, we've collected data, now let's put our data together and get some answers. Our angle, remember we called our angle theta. So theta equals 27 degrees. We measured the adjacent, and it was slightly off ahead on one and slightly behind on another, so we're just gonna call it 19 feet because it was off by a half a foot either way. So let's call our adjacent 19 feet. Now remember, we're solving tangent of theta equals the opposite over the adjacent. So now we know this variable, so we're gonna solve for this variable. So let's actually just solve for opposite now. It's gonna be a teeny bit easier. So the way we're doing that is we're gonna multiply each side by a. Let's actually bring it down over here. Tangent of theta equals the opposite over the adjacent. So let's multiply each side by a, by the adjacent. So that crosses out. And this becomes, what we're solving, the opposite equals the adjacent times tan theta. Now we know that let's keep going. So the opposite equals the adjacent, which we know is 19 feet. Tan of theta, tan of 27. Let me show you that. Remember, that sounds confusing, but it's really just another plus or minus or division sign. It's just another mathematical function. So don't think about it too much until you're in the class and you have to prove it. Go to your calculator on your phone, rotate it. Now you're going to get these, you're going to see sine, cosine, and tangent. This needs to be in degrees to work, so if it says radians down there, you're right. Don't hit radians, you want this in degrees. So for the iPhone, you're typing in the number first. 27 tangent. 5, let's round that up to 0.51. And now times 19. Now you would think, is the height of the tree really just 9.68? So let's just round that up to 9.7 feet, because that's what the opposite is saying. The opposite is 9.7 feet. But let's go back to our picture. I did that off of my eye level. I'm a relatively short guy. I'm only 5'6", so we have to add 5'6" to this number. This is going to be 5.5 because we're in percentages. All right, so that short tree is 15.2 feet tall, and that looks about right. Same measurement, same process for the big tree. Let's run through the tall tree really fast. You just saw me collect more data. Let's do it. So the opposite is still unknown because the situation is still the same. We can't measure the hypotenuse, but we can measure the adjacent, and we want to know the opposite, and we know theta, we know the angle. So for SOHCAHTOA, that's perfect for TOA, which means tangent, which means the tangent of theta, tangent to the angle, equals the opposite divided by the adjacent. I'm telling you because I just measured it. Theta is 22 degrees. And the adjacent we're going to do in meters is 37 meters. Not meters, 37 yards. So let's rewrite this so it's more useful for us. Remember, we're going to multiply adjacent by both sides, so we're going to be left with the opposite equals the adjacent times the tangent of theta. Now let's plug it in. Opposite equals A, which is 37 yards, times the tangent of theta. Oops. Which is the tangent of 22. Okay, this time let's do it on a scientific calculator, just in case hopefully some of you have these still. So, to make it easy, let's do the tangent of 22 first. So let's type in 22 in tangent, and you can see we're on degrees, which is good. So 0.4, that's what we wanted to see. Or that's what I expected to see. And now times 37. So that's going to be 14.94. Let's just call that 15. Let's call that 15 meters. So the opposite equals 15 yards. But remember, that's only from my eye height. I'm 5'6". Let's just assume for the fact, same thing I did in middle school and high school, that I wish I was a little bit taller. Let's call me 2 yards at 6 feet, just to make the math easier. So plus 2. 17 yards. Let's show what that is in feet. So it's times 3 feet. 3 times 7 is 21. 3, 4, 5, so 51 feet. There you go. So 2 examples of how you can measure the height of a tree on your own with easy to acquire materials and really simple math. Just because it's trigonometry and you're in just math 1 or something like that doesn't mean you can't do this. All you have to do is plug and chug. Plug it into the equation, get an answer, and you know your height of the tree. Thanks for watching. Have a good day.